Natural language processing is getting more and more popular these days, and many people ask what it is and with what topics it exactly deals. In this video, I'm going to present you a compact poster with examples and subfields of NLP. Hi, my name is Josh Gonsirazadeh from the University of Luxembourg. In the last decades, I worked and did research in different fields of AI like deep learning, natural language processing, data mining, or digital humanities. As the name suggests, natural language processing is a field of study which deals with the processing or digital application of natural human language. If we put it into simple words, it's mostly about how to make computers to understand or to produce human language. NLP is widely used in many applications on your computer or on your phone in the tools like Siri or Amazon Alexa. Even your Google Assistant can understand your spoken commands. The field has a bright future because the language is the best and the easiest way for us humans to communicate. What do we mean with natural languages? These are languages like English, French, German, Chinese, and many others we use in day-to-day communication. It presents itself mostly in one or two forms. First, in the form of spoken language, which can also be recorded, and secondly, in the form of written language, like a text in internet or in social media. Classically, the field of the study of languages is called linguistics. In fact, it has a tradition of more than 2000 years of research. Usually, linguistics is divided into the study of sounds, called phonetics, which investigates the smallest building blocks for a language, called phonemes, the study of the meaning of the words, also called lexicology, the study of morphology, which deals with the inner structure of words or how they can change in order to express certain abstract categories like plural in nouns or past in verbs, and into a study of syntax, how, for example, words can be combined in order to build valid sentences. Let's start then with the technologies used in order to deal with the smallest building blocks of a language. The first one is speech processing. It deals with how an audio signal of human speech can be transferred into a text, or in a simplest form, how phonemes can be transformed into characters. Please be careful, phonemes and characters are two different pairs of shoes. This field is also related to signal processing and can use modern deep learning technologies in order to achieve better results. As our next subfield, we are going to discuss a family of algorithms which deals with aforementioned characters. It does not matter if they were created manually or automatically. These algorithms can, for example, help in automatic spell checking, where a software corrects misspelling while you type. Other applications are OCR, which stands for Optical Character Recognition. Here, a picture of a text is converted into text. Also, the distribution of characters can already give information in order to detect the language of a given text. The next subfield deals with the morphology of words. Here, we can classify words by their word class by assigning each word with its own word class label. By doing this, we can differentiate between nouns, adjectives, verbs, and so on and so forth, because they carry different kind of information and express different grammatical categories. Another thing which can be done with words is called stemming or lemmatizing. The first technique reduces the words to their stems or roots, and the second one to their lemmata. By doing this, one can, for example, search a text much easier by using only the root of a word and by finding its all forms or flections in the text. The next part of research in NLP deals with the semantic of the words. One important field in it is called distributional semantics. By looking at the surrounding of words or at the context the words are used, one can determine their meaning. Also, the distribution of words can be helpful in extracting fixed phrases from text which can often have metaphorical meaning. Thanks to advances in this field, we have technologies like word embeddings, which can be very useful not only in finding semantically similar words, but also can be used in many NLP applications like sentiment analysis. We will talk about sentiment analysis more in detail soon. The next field I want to discuss is about the syntax of a language, or about how valid sentences are and can be built out of words. Every language has a specific word order, and words play a different role in a sentence. For example, for English language, a typical structure of a sentence considered to be subject, verb, object. But it is not the case for other languages. In German, for example, in some cases the verb goes to the end of the sentence. Syntactical parsing can be used in order to better understand the text. It takes a sentence and identifies things like subject or object in the sentence. Another application would be if one wants to develop a software for translating a text from one language into another. Here, just to substitute the words with their respective counterparts in another language is in most cases not sufficient. For this purpose, one needs a syntactic information in order the new created text to be readable. Otherwise, the created text would seem and sound some sort of mechanical. You notice we are moving already towards more complex building blocks of a language. Because these are bigger language units, information from smaller units can be leveraged. In parsing, for example, one can use part-of-speech labels of a word. Subjects and objects are usually expressed with nouns, and verbs denote more the action. With this in mind, we will jump into our next subfield, which deals with the overall structure of text. How can topics be expressed in a text, or how this information can help us to extract topics automatically from the text? Would it be not awesome to have the possibility to identify topics automatically in huge text collections? Nowadays, it's more relevant than ever with exponentially growing of data in forums and in social media. Another example would be to identify a piece of text, like in a user comment, if it's positive or negative. The field which studies this phenomenon is called sentiment analysis. In modern-day sentiment analysis tools, which are usually implemented with the help of deep learning architectures, we benefit from word embeddings as additional information, because word embeddings, as mentioned before, can give information about semantics of words. So a system designed this way, if it knows that a sentence like "it is nice" is positive, other sentences like "it is awesome" or "it is terrific" would have the same sentiment, because the words nice, awesome, and terrific are semantically similar. Another subfield of NLP is about conversation analysis. This field is crucial, for example, in developing chatbots. Usually, an ideal artificial companion or a chatbot tries to make a conversation in most human way possible. For this reason, we need to do research and understand how humans start and end conversations, how they act in certain situations, how they follow certain etiquettes, and so on and so forth. Chatbot and artificial companions are broadly used in many fields and can help in reducing cost and human power in many companies. So, to sum it up, NLP is a field which investigates how to implement systems for dealing with natural languages. Meanwhile, it has become a crucial part of the industry. Thank you guys for watching, and see you in the next video. Bye bye.